Welcome back to Azure AI Essentials. Today, we're going to take a look at how you can use Azure Cognitive Services in containers. These containers allow you to use the same APIs that are available in Azure on premises to give you the flexibility of bringing cognitive services closer to your data for compliance, security, or other operational reasons. Let's dive right in. So, what is a container? A container is a standard package of software that bundles an application's code together with the related configuration files and libraries, and with the dependencies required for the app to run. This allows developers and IT pros to deploy applications seamlessly across environments. You might be thinking that this sounds similar to using a virtual machine. So how is this beneficial? Containers are different from virtual machines in the sense that they can be isolated from each other and their underlying operating system. Everything you need to run an application is contained in the container, removing dependencies on the host environment. This makes your application more portable and efficient. Essentially, we've taken the same exact machine learning models, code repositories, and model code for cognitive services web APIs and packaged it in a container image. These container images can run on-premises, such as in data centers or Azure Stack Hub, or they can run on orchestrators like Kubernetes and Red Hat OpenShift. They can even run on edge devices, like our recently announced Azure Percept devices. With containers, you can process your data anywhere and still have access to Azure Cognitive Services APIs, giving you the added benefit of flexible deployment. Currently, Azure Cognitive Services provides several Docker containers, such as decision containers for Anomaly Detector, language containers for text analytics, vision containers for computer vision and form recognizer, and many more. These capabilities offer increased flexibility to our customers to apply AI to their specific business needs and environments. Take, for example, TIBCO, a software provider that helps its customers embark on their digital transformation journeys. TIBCO uses Azure Cognitive Services and containers as an underlying technology for its anomaly detection solutions to detect and analyze sudden changes in data patterns. TIBCO's anomaly detection solution discovers root causes and provides suggested actions with a ready-made solution that eliminates development time for their end customers. As a developer, you may think that a sophisticated solution like this would take months to develop, especially if you're dealing with a power plant or manufacturing facility with limited connectivity. But it's actually quite simple to get started with. Let's take a look at how you, as a developer, would deploy the Anomaly Detector container. Before you begin, you'll need the Docker engine installed on your computer and configured to allow containers to connect with Azure. The first step is to create an Anomaly Detector resource. You can search in the Azure Marketplace to find it, and then create a new resource group. Once you've reviewed and created your Anomaly Detector resource, you can gather your API endpoint and key. Both of these will be used when you deploy the container. At this point, you can go to Docker Hub to pull the Anomaly Detector container image. Make sure you have Docker running on your desktop. Then open up the command window and provide the Docker pull. This will enable you to pull the latest Docker image of Anomaly Detector. While that's loading, let's grab the Docker run command to spin up the Docker container instance. You can find this for each of our cognitive services containers online, along with a recipe for specific container instances. Copy the Docker run command and replace the API endpoint and key portions with your real endpoint and key you previously gathered from the Anomaly Detector resource. You can see that it's listening on port 5000. We can now make an API call against this container. A great way to verify if the container is functioning properly is to navigate to the HTTP endpoint and see that it's up and running. You can also view the Swagger file that describes the APIs and capabilities. Now, Anomaly Detector ingests time series data of all types and allows you to select the best-fitting detection model for your data. You can adjust the sensitivity of the backend API to adjust filtering on the data points collected, and you can pinpoint where specific anomalies occur. And just like that, your container has been created and is ready to use as you would a typical Web API Anomaly Detector service. In general, the use of cognitive services in containers follows a generic workflow of creating the resource in Azure, getting the endpoint, retrieving the API key, finding the container for the service, deploying the container, and using the container endpoint as you would use the API resource. In fact, the use of cognitive services in containers is exactly the same as if you would use them in Azure. Now, if you want to perform these steps without having to manually navigate the Azure portal each time, here's a pro tip for you. Use the Azure Command Line Interface, or CLI, in combination with Azure Container Instances. The Azure Command Line Interface is a set of commands used to create and manage Azure resources and is available across Azure services. It's designed to get you working quickly with Azure with an emphasis on automation. So how do you actually use the Azure CLI? Let's walk through an example. This time, let's run a cognitive service speech container in an Azure Container Instance and use the REST API to convert text to speech. To begin, make sure you have the Azure Command Line Interface installed. To create a resource group in Azure CLI, you need to specify two parameters: the name of the group and the location of where the group is deployed. Next, we're going to specify that we want to create the speech cognitive service. After the speech service has successfully deployed, we can extract the endpoint URL and the API key. Now, I mentioned that we'd use Azure CLI in combination with Azure Container Instances, and here's where that comes into play. Azure Container Instances offers the simplest way to run a container in Azure without having to adopt a higher-level service. It's also a great solution for any scenario that can operate in isolated containers, including simple applications, task automation, and build jobs. With a single prompt in the Azure CLI, you can deploy a container and make it accessible by everyone. To create an Azure container instance, you need to feed it a few parameters. If you want your container instance to be accessible from the internet, you'll need to specify the parameter DNS name label. Copy and paste the billing endpoint and API key and hit enter. The deployment of our Azure Cognitive Service is underway and will only take a few minutes. To validate if the container is running, you can use the same approach as before by using a browser and navigating to the container's homepage. Retrieve the URL using the CLI and navigate to the URL on port 5000. You can now see that our speech container is up and running. To test our service, we'll need to create a post request. I'm going to do this using a program called Postman. In the request, we can specify the voice we want, as well as the text we want to convert to speech. Let's try it out.
Hello, world.
And there you have it. So now that we've explored what containers are and how to use them with Azure Cognitive Services, you've been armed with the flexibility to cater to your own applications. Flexible deployment of Azure AI services enables you to continue developing mission-critical solutions with the most mission-critical tools. For more information on flexible deployment options of Azure Cognitive Services, please visit our online documentation. Thanks for tuning in to another episode of Azure AI Essentials. We're excited to see what you create with the endless options of flexible deployment available to you.